Good evening, children.
Good evening.
Good evening, children. Am I audible?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yeah. So last class, we were discussing about how a linear equation in one variable can also be treated as a linear equation in two variables. Correct? Did I tell you that, children?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Just give me a second. Just a second, children. Yeah, okay. So that's where we stopped in the last class. So I was telling you that a linear equation in one variable x can also be treated as a linear equation in two variables x and y. That's what we were seeing in the last class. I think we took up one example. Just tell me the equation which we took up in the last class. The last equation.
2x plus 3 equals to 0.
2x plus 3 is equal to 0. Thank you, Sanjay. 2x plus 3 is equal to 0. All right, so on solving this, what do we get? X is equal to minus 3 by 2. So when you treat 2x plus 3 is equal to 0, now we know that this is a linear equation in one variable x. It's very clear that 2x plus 3 is equal to 0 is a linear equation in one variable x. And we also know that a linear equation in one variable has one and only one solution. And that solution here is minus 3 by 2, which means minus 3 by 2 is the only value of x that can satisfy this equation. Minus 3 by 2 is called the solution to this equation 2x plus 3 is equal to 0. Why? Because that is the only value of x which can satisfy the equation 2x plus 3 is equal to 0. So which means in the LHS 2x plus 3, in the LHS 2x plus 3, in place of x, when you use minus 3 by 2 and work it, you get minus 3 plus 3, which is 0, which is the RHS. See, the RHS is 0, which is the RHS. So the LHS can be equal to the RHS. The LHS is 2x plus 3 and the RHS is 0. The LHS can be equal to the RHS only when x is equal to minus 3 by 2. For no other value of x will the LHS be equal to the RHS. That means there is no other value for x which can satisfy the equation. So this is the only solution. Minus 3 by 2 is the only solution to this equation. And we also know that this equation can be geometrically represented. That is the solution to this equation. The solution minus 3 by 2 of this equation 2x plus 3 is equal to 0 can be geometrically represented as a point on the number line. The geometrical representation of the solution is given by a point on the number line. All right. So now this is minus 3 by 2. So 0, minus 1 by 2, minus 2 by 2, minus 3 by 2, minus 4 by 2, minus 5 by 2. It goes on like that. And minus 2 by 2 is minus 1. Minus 4 by 2 is minus 2. And this is what we want, minus 3 by 2. So x is equal to minus 3 by 2. So this is how we represent the solution on the number line. Which means a linear equation in one variable, x, y, whatever, in one variable, the solution to the linear equation in one variable is represented by a point on the number line. The solution to the linear equation in one variable x is represented by a point on the number line. I don't know if I wrote this in the last class, but just to make sure, I'll just write it again. So the solution to the linear equation in one variable x, in one variable, any variable, okay? So here it's one variable x, any one variable is represented by a point on the number line, by a point on the number line. We're recalling, we did all this in the last class. So now, again, this part which we already discussed in the last class, this linear equation in one variable x can also be treated as a linear equation in two variables x and y. All right. Just 1 minute. No, I just take pictures. So when I've not prepared the PPT, I just take the picture so that I can just write the same thing in my PPT. So that's why I just turn off the video to take a photo. To take a picture on my camera, I just turn off my video. Yeah. So let me erase the screen. So now the same equation 2x plus 3 is equal to 0, which is a linear equation in one variable x, can be treated as a linear equation in two variables x and y like this. This is not 0 point y, it is 0 into y. It's not 0 point y, it's 0 into y. Instead of writing 0 into y like this, we write like this, 0 into y like this. Or simply 0 y. Or you will also see this 0 point y. It's not point, 0 y it is. Don't read it as 0 point y, it's 0 y. Meaning 0 into y, which is 0. So 2x plus 0y plus 3 is equal to 0. Now you can see that this equation has two variables x and y. Has two variables x and y. Now this equation, which is an equation on two variables x and y, has infinitely many solutions. Because when you try to represent this geometrically, it's given by a straight line on the Cartesian plane. A linear equation in two variables x and y is represented by a straight line in the Cartesian plane. And we know that a straight line has infinitely many points lying on it. And hence, and every point lying on the line, every point lying on the line is a solution to the equation. And that is why we say that a linear equation in two variables x and y has infinitely many solutions. So now this one, 2x plus 0y plus 3 is equal to 0. You know that you have not changed the value of the given equation. It is still 2x plus 3 is equal to 0 because 0y is nothing but 0. So you have not changed the meaning of the given expression 2x plus 3 is equal to 0. There is 0y, but it's still 0. So there, you have not altered the value of the equation. It is still 2x plus 3 is equal to 0, but you can see the y variable there. You can see it there. Okay, now, so how do we make a, to get the straight line, to get the representation, the geometric representation, what do you have to do? You need to prepare an XY table because there are two variables x and y. There are two variables x and y. So you need to find, give values for x and find the corresponding values of y. Or in some cases, you'll have to give the values of y and find the corresponding values of x. So we'll learn all that later. Now for this one. For this one, when you solve it, what do you get? X is equal to minus 3 by 2. X is equal to minus 3 by 2. When we solve 2x plus 3 is equal to 0, we get x is equal to minus 3 by 2, which means x is always minus 3 by 2 for any value of y. For any value of y, any value of y. X is equal to minus 3 by 2 means x is always, see, x is always minus 3 by 2 for any value of y. We also checked this in the last class. We also checked this in the last class. I'll just show you for one now. We did for all the three solutions in the last class. Now let's check for this solution. Let's check for this one. Let's check for this one. So 2x plus 0y plus 3 is the left hand side. See, if you solve this one also, this you will get the same thing. X is equal to minus 3 by 2. Solve this. 0y is nothing but 0. So 2x is equal to minus 3. X is equal to minus 3 by 2. You will get the same thing. Not that you should solve this one. You solve this one. You will get the same thing. X is equal to minus 3 by 2. All right. So now take up the LHS. 2x plus 0y plus 3. Now 2x, what's the value of x? See here, what's the value of, we are trying to see if this, what did we understand? X is always minus 3 by 2 for any value of y. That's what we understood. Now we are trying to check if these values of x and y satisfy the equation. They must satisfy. They must satisfy. You cannot write some random value for x and y. If you have taken some value for x and a corresponding value for y, this pair should satisfy the equation. This pair should satisfy the equation. So in place of x, we use minus 3 by 2. And in place of y, we use 5 plus 3. What should we get? 0. Because the RHS is 0. We must get 0 when we simplify this. So 0, 2 gets cancelled. Minus 3. 0 into 5 is 0. It is 0 plus 3. So minus 3 plus 3 is 0, which is the RHS. Which is the RHS. So clearly minus 3 by 2 comma 5 satisfies this equation, and hence it's a solution to the equation. It satisfies. Similarly, when you use these values for x and y, they will also satisfy the equation. So the values of x and y which we have taken are accurate, are correct. And now, so this is new for the class, meaning we did not see this graphical representation in the last class. So from here, listen carefully. So this was a recall of the end session of last class, meaning the last part of last class. Okay, so now we'll see how we represent this in a Cartesian plane. Why Cartesian plane? Because there are two values, x values and y values. So you need the x-axis, the y-axis. Okay, so let's take the x and y axis. So x dash, y dash. So are we familiar with graphs, children? Is there anybody, meaning do you feel, since coordinate geometry we have not done this year, but are you all aware about plotting points on a graph paper?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So supposing the point 1, 2. Now, very simple thing about coordinate geometry you need to know. You just need to know how to plot the given points. That's all. Nothing else you need to know. So when it is like, say, 1, minus 5, you should know how to plot this point 1, minus 5 in the Cartesian plane. That is enough. That's all you need. Okay. So now let's plot this. So minus 3 by 2 is nothing but minus 1.5. Minus 3 by 2 is nothing but minus 1.5. So we need to plot minus 1.5 comma minus 5. So roughly I'm doing it. Okay, minus 1.5. Okay, so like minus 1, minus 2. So this is minus 1.5 comma minus 5. So down here, minus 1, minus 2, minus 3, minus 4, minus 5. Somewhere here, this is because this is minus 1.5. This one is C of minus 1, minus 2. Between that is minus 1.5. And minus 5 on the y-axis. Here it is minus 5. So this is the point. Minus 3 by 2, comma minus 5. Next, 1.5, minus 1.5, comma 0. Minus 1.5 is this one. Minus 1.5 and comma 0. So this itself, this point itself. This one. This is minus 1.5, minus 3 by 2, comma 0, comma 0. And then we need to plot a minus 1.5, comma 5. So this is minus 3 by 2 or 1.5, comma 5, comma 5. All right, so 5 is a positive 5. So 1, 2, 3, 4, 5 here. Okay, this is 5. This is minus 5. All right, so minus 3 by 2 on the x-axis here and 5 here. This one. This one is minus 3 by 2, comma 5. So we have plotted. These are called ordered pairs. These are called ordered pairs, or what you see here, you know, minus 3 by 2, comma 5. They're called ordered pairs. It's an ordered pair because the order is very important. because now minus the location of -3/2 comma -5 is different from the location of -5 comma -3/2 in the Cartesian plane. The location of this point is different from the location of this point. That is why it's called an ordered. Order is important. Ordered pair. Pair because two numbers. Pair because two numbers, -3/2 and 5. There are two numbers. So pair. Ordered pair because the order is important. -3/2 comma -5 is not the same as -5 comma -3/2. They are different. When is it the same? If both the if it is like -4 comma -4, if both the numbers are the same, if the x coordinate is equal to the y coordinate, if the x coordinate is equal to the y coordinate, then even if you exchange it, it is the same point because they're equal. When the values of x and y, they're equal. When the value of the x coordinate is equal to the value of the y coordinate, then even if you exchange it, it's still the same point, -4 comma -4. If you exchange it, also it is -4 comma -4. Otherwise, it is not. Otherwise, it's not. The location is different. Okay. Okay, so that's why ordered pair. Ordered because the order is important. Pair because two numbers, x coordinate, y coordinate. So it's called an ordered pair. So these are the -3/2 comma -5 is an ordered pair. -3/2 comma 0 ordered pair. -3/2 comma 5. And these are also solutions to the linear equation. Okay. Now what happens when you join? This was what? -3/2. Okay. Now when you join, children, you'll have to, that's what you'll have to do. After marking of the 3 points, you'll have to connect the points by a, you'll have to try to connect the points. When you join the 3 points, you must be able to connect all the 3 points by the same straight line. You should be able to join the 3 points by the same straight line. Okay, it should not be like there's 1 point here, 1 point here, 1 point here. It shouldn't be like something like this. No. If they're not linear, if you're not able to join the 3 points by the same straight line, you've gone wrong somewhere. Somewhere you've made a mistake. So now if you can see here, I can join these points by the same straight line. By the same straight line. It won't be crooked like this, children, please. It will be a same straight line. If you use a scale and connect it, it'll be the same straight line. So like this, you get the graph. Like this, you get the graph. So here on the graph, you must write the equation. Okay, 2x plus 0y plus 3 is equal to 0 on this graph. Okay, you should write it like this. I'm not able to write now. Like here, you should write 2x plus 0y plus 3 is equal to 0. You should write the equation. What are the requirements of a graph? You must write the scale. We'll see all that when we do the real graph. I'll tell you how to write the scale. You might have already learned it. We'll still see it. So these are like when you cover your book. To cover a book, what all you need? You need a brown paper. Okay, so a brown paper you need, and then you need a label. You need a writing instrument to write your name and fill in the section, school, and all that. So it's so to cover the book, you need a pair of scissors. Okay, you need a pair of scissors. So you need certain things, right, to cover up your book and label it, write your name and other details on the label. So like that graph, there are some requirements. So if you cover your book and put a label on it, but you have not written your name, nothing, subject name, standard, nothing you've filled. It's empty, right? So when the teacher distributes a book, she would have put a question mark on the label. I don't know if teachers do it now. Otherwise, nowadays, the teacher will put a question mark on the label and she'll, show it to the class and ask whose book is this. So like that, a graph is incomplete without a scale. You have to write the scale. You have to write the scale. You have to write x dash, indicating the x-axis. You must say y dash, y-axis, and the arrows, very important, arrows, indicating that it's a line. It's not restricted to your graph paper. It is now within the bounds of your graph paper because that's the size of your paper. Otherwise, it's a line. It extends indefinitely on both the sides. So x dash, y dash. And then, of course, the graduations you must show like this and write whatever 1, 2, 3, 4, all that you must show. This is the origin 0, 0. This is the origin 0, 0. Show the arrows because the y-axis is also a straight line. And then whatever points you plot, you must write the coordinates. Like you cannot simply just mark the points and join. You should write. This is minus 3 by 2, 5. This is minus 3 by 2, 0. Minus 3 by 2, minus 5. So scale. Then whatever points you have plotted, you must write the the address of that point. That is that ordered pair you should mention, which shows the x coordinate and the y coordinate. And of course, when you join the 3 points, you should be able to join the 3 points by the same straight line. And again, it's a line, so arrows. And then writing the equation on the line here. Okay, I'm not able to write it like this 2x plus 0y. Okay, I hope you all understand. Plus 3 is equal to 0 like this. Plus 3 is equal. Don't write on something. So like this, you must write the equation on that line. And now this line has so many points on it. Every point will satisfy this equation. This line has infinitely many points lying on it. And every point will have an address. Now, if you take this point, it will be like minus 2, 5. If you take this point, it will be minus 3, 5. If you take this point, it will be, oh, sorry, not this one. Be minus 3 by 2, sorry. Yeah, if you take this point, say this point will be minus 3 by 2, it will be kind of 2 or 3 here. This one, 1, 2, 3, right? So minus 3 by 2, 3. Then this point like minus 3 by 2, 4. So many points on this. Below also minus 3 by 2, minus 6. Goes on like that. All these points will satisfy the equation. Every point lying on this line will satisfy this equation. And since this line has so many points on it, infinitely many points on it, this linear equation in two variables x and y has infinitely many solutions. So if you treat 2x plus 3 is equal to 0 as an equation in one variable x, the solution is represented by a point on the number line. The same equation in one variable x can be treated as a linear equation in two variables x and y, in which case it has infinitely many solutions. Its graphical representation is a straight line. To obtain the straight line, you'll have to make a xy table. Make an xy table. So here we know that x is always minus 3 by 2 for any value of y. Plot the points, obtain the straight line. Now, now you can just make a note of this roughly, children. Make a note of this. Just take down whatever you see on the screen. Let's make it, yeah, 1 second. Let's make it fast, children. If you can, okay, you can use a scale, but just make it fast. Yeah, yes. Somebody wanted to ask something, please.
Ma'am, this is Tanishka, ma'am.
Yes, Tanishka.
Ma'am, in our school, they told that graph is a deleted portion, ma'am.
Tanishka, I'll tell you, without this next year, making graphs will become difficult. So, yeah, so here we'll learn it. Though it is deleted, yeah, 10th standard becomes difficult.
Yes.
10th standard, yeah, so certain things we have to learn. Only then, because you have graph making next year also.
Yes, ma'am.
And next year, we don't know if that will be deleted. Now, this year, children have no linear equations and they have graphs in it. Yeah, so that's not a very difficult part. And I'm not doing it in great detail also. I'm just you'll see. We'll finish it fast. Don't worry.
Yes, ma'am.
Yeah. In some schools, they will do, even if it's deleted, because it's important for next year, teachers might do. Has anyone learned linear equations in two variables in school already?
Yes, ma'am.
Yes, ma'am.
Yeah. Who's learned?
I'm Rajan.
Ma'am, me Madhumita.
Ma'am, we also have one.
Ma'am, me Danya. Ma'am.
Tanya also. Okay, now tell me, have you learned graphs in school or no?
Yes, ma'am.
Yes, ma'am.
Yeah, that's what it is. Because it's important. It is important. Constructions has been deleted fully. And constructions, even if this year, construction has been deleted fully. And even if you don't learn it, it's okay. Next year construction, you can still understand. So that I will not do. Something which is deleted and will not be required for your higher classes also, I'll omit. But certain things are fundamentals. Only then you will find next year easy. So such things I will do it here in the class. You have to learn it. Yeah. No, I hope all of you, believe me, meaning what I'm saying makes sense, right? It's deleted from this year, but for next year, graph making, when you see this year, you will be making only one line on the graph paper, but I will be telling you how to make a triangle also. We will learn some aspects. We learn, actually, I will do it in detail only. See, I cannot, graph making, I will do it in detail in this class. Then next year becomes easy for you. You don't have to really spend time on, understanding graph. It's so easy. And you can concentrate on other things which are very new.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am.
Yes, children. Yes. Yeah. Make a rough sketch of the graph. The graph alone, I just want to do it again. Copy the equation and the table. I'll do the graph again for you.
Ma'am, we copied the table and equation last class.
Okay, okay. Oh, then I'll make the graph now. I'll make the graph. So see, oh my God. So like this, y-axis, x-axis, arrows, x, x dash, y, y dash, scale, x-axis 1 centimeter is equal to 1 unit, y-axis, 1 centimeter is equal to 1 unit. Then 1, 2, 3 and all that, -1, -2, -3. So here is -3 by 2, 1.5. And -1, -2, -3, -4, -5. 1, 2, 3, 4, 5. Now this is -3 by 2, comma -5. -3 by 2, comma 0. -3 by 2, comma 5. Join. Straight line. Write the equation on this. Write the equation on this. 2x plus 0y plus 3 is equal to 0. 2x plus 0y plus 3 is equal to 0. Write the equation on this. And this point is given by -3 by 2, comma -5. Write that. This point is -3 by 2, comma 0. Write that. And this is -3 by 2, comma 5. Write that. So equation on the line, the points which you have plotted, scale. Now this is complete. The graph is complete. So like you fill your name, standard section, subject, classwork, homework, school. Similarly here, x-axis, x dash, y dash, scale. The 3 points which you have plotted, their coordinates, arrows everywhere important, and write the equation on the line. This one, write the equation on the line. Done, children, all of you?
Yes.
Completed, ma'am.
Yes, ma'am.
Completed, ma'am.
All right. Now, supposing we have an equation like this is another example. So you have say 3 by minus 12 is equal to 0. All right. 3y minus 12 is equal to 0. How will you treat this as a linear equation in two variables x and y?
3y
0x
plus
plus
3y
3y
minus 12
minus
equals
12 is equal to 0. When you solve this, what will you get? 3y is equal to 12. Y is equal to 12 by 3, 4. 4. So how do we make the table? How do we make the table? The table is y is always 4. See, I'm dragging the way I say y is always 4. Y is equal to 4 means y is always 4. For any value of x, any value of x, any value of x. Don't take 100, 200 and all that. You should be able to plot it on the graph paper. Okay, so y is equal to 4 means y is always 4 for any value of x. And again, when you check, I'll just check for one. We'll check this one. Let's take up the LHS. Let's take up the LHS. 0x plus 3y minus 12 is equal to 0. So x is 3. So 0 into 3. X is 3. Please see that. 3 into 4 minus 12 is equal to 0. So 0 into 3 is 0. 0, it's not 0 0.3. 0 into 3, 0 plus 12 minus 12 is equal to 0. Oh, sorry, I shouldn't write as equal to 0. What happened? Sorry, children, you should not write is equal to 0 because you're checking. Okay, is equal to 0 plus 12 minus 12, which is 0, which is 0, which is the RHS. So you can see that the LHS is equal to the RHS. LHS is equal to RHS. So that means 3 by 4 satisfies the equation. Now we'll plot it. So like that, you can check every pair. They will satisfy the equation. Now, how do we make the graph for this? Okay. Now plot these points. Minus 3, comma 4, minus 3. 1, 2, 3, minus 3, comma 4. 1, 2, 3, 4. Okay, so rough. Minus 3, comma 4 is here. 0, comma 4. 0, comma 4 will be here. And 3, comma 4. 3, comma 4 will be like this. So when you join, it's like this. Yeah. Yeah, take this rough graph, children, all of you. Of course, see, if I don't mark all this, you mark it, please. X dash always. Y dash. And what else? The equation 0x plus 3y minus 12 is equal to 0. 0x plus 3y minus 12 is equal to 0. That's the equation. And these points are minus 3, comma 4, 0. This is 0, comma 4, 0, comma 4, and this is 3, comma 4. Please do this, children. I'm just coming back. Okay, children. So what did we notice in the last graph? Yeah, the previous graph, what do you see? When the equation, what was the equation for this one? 2x 2x plus 3 is equal to 0. 2x plus 3 is equal to 0. And the solution is x is equal to minus 3 by 2. How do you see the graph when it is x is equal to minus 3 by 2? It's parallel to the y-axis. It's parallel to the y-axis. When you treat this as this is the earlier graph. This is the first graph. So 2x plus 3 is equal to 0. We treated this as a linear equation in two variables x and y, and we made the graph. The solution is x is equal to minus 3 by 2. So x is equal to minus 3 by 2. How does the graph look like? You can see that the graph line is parallel to the y-axis. The graph line is parallel to the y-axis. The graph line is parallel to the y-axis at a distance of 3 by 2 units to the left of the y-axis. See here, whenever you have x is equal to some number, like say a or minus a or minus a. Normally in the books you will find only x is equal to a. I'll just now to make you understand, I'll just say a and minus a. Okay, actually in the books you will see only x is equal to a. Just to make you understand, let me say a and minus a. X is equal to a, x is equal to minus a. Whenever you have x is equal to a constant, x is equal to a constant, x is equal to something, then that line will be parallel to the y-axis. Just remember like that. You can see the graph here. I'm not asking you to, believe something blindly. You can see the graph here. Okay, so you can see the graph right in front of you. And this is when x is equal to a. Okay, this is minus 3 by 2. No, so let's say minus a. X is equal to minus a. So whether it is x is equal to a positive value or x is equal to a negative value, the graph line will be parallel to the y-axis. X is equal to a number. Remember, x is equal to some number. X is equal to some number. Okay, and you have to treat it as a linear equation in two variables x and y. Then the line will be parallel to the y-axis. X is equal to a number, a constant, means the line will be, when you make the graph, that graph line will be parallel to the y-axis. Now the next question is, okay, it is parallel to the y-axis. Will it lie to the left of the y-axis or to the right of the y-axis? There are two positions, no? When it's parallel to the y-axis, there are two positions. So this is these are the x and y-axis. So supposing it's here. The line can be here or the line can be here like this. This is the y-axis. This is the y-axis. This is the x-axis. And these are the graphs we have got. This one and this one. Okay, these are the graphs we have got. Now, when the graph line is parallel to the x-axis, y-axis, when the graph line is parallel to the y-axis, that means it's like x is equal to something. The equation is x is equal to something. Now, if x is a negative value, it will be to the left of the y-axis. And if x is a positive value, it will be to the right of the y-axis. Now, this will be, say, like x is equal to 3 by 2. And this is x is equal to, this graph is x is equal to minus 3 by 2. There are two positions. When the graph line is parallel to the y-axis, there are two positions. Is the graph line, does the graph line lie to the left of the y-axis or to the right of the y-axis? Is it on the right side or the left side? Is it on the right side of the y-axis or on the left side of the y-axis? If x is equal to a positive value, it lie on the right side. If x is equal to minus a, that is a negative value, it will lie on the left side. So here we have 2x plus 3 is equal to 0. Or in other words, x is equal to minus 3 by 2. This 2x plus 3 is equal to 0 only is x is equal to minus 3 by 2. See, like when you work this, cross multiply, x is equal to minus 3 by 2. Cross multiply, what do you get? 2x is equal to minus 3. 2x plus 3 is equal to 0. That equation only. When I say x is equal to minus 3 by 2, when you cross multiply, am I clear, children?
Yes, ma'am.
When we cross
Yes,
multiply,
ma'am.
yeah, when we cross multiply, what do you get? 2x is equal to minus 3. 2x plus 3 is equal to 0. That's what this equation only. So x is equal to a negative value. X is equal to means x is equal to a constant. The graph line will lie parallel to the y-axis. Left side or right side? If x is equal to a negative value, left side. If x is equal to a positive value, right side. So supposing it was x is equal to 3 by 2, a positive 3 by 2, then it will be on the right side of the y-axis. So when the equation is x is equal to a constant, it'll be a line parallel to the y-axis. If the constant is positive, it'll be on the right side of the y-axis. If the constant is negative, it'll lie on the left side of the y-axis. Now we saw this one. We saw this one. Yeah. What was this? Y is equal to 4. Y is equal to 4. Y is equal to 4. So y is equal to a constant. Y is equal to a constant. All right. So when y is equal to a constant, it will be a line, the graph of this equation. That is when you treat this as a linear equation in two variables x and y, the graph will be a line parallel to the x-axis because y is equal to a number. Remember like this, you can see the graph here. You can see the graph here. How did we get y is equal to 4? It's parallel to the x-axis. You can see it's parallel to the x-axis. Y is equal to 4. This line, the graph line is parallel to the x-axis. So when the equation is y is equal to a constant, y is equal to a constant, then the graph of that equation will be a line parallel to the x-axis. Y is equal to something, no? So it will be parallel to the x-axis. Now the question is, will it lie above the x-axis or below the x-axis? Because with respect to the x-axis, there are two positions, above the x-axis, below the x-axis. With respect to the y-axis, it is to the right of the y-axis, to the left of the y-axis. We can't say above the y-axis, below the y-axis, because y-axis is vertical. Y-axis is vertical. So we say to the right side of the y-axis or to the left side of the y-axis. But the x-axis is horizontal. The x-axis is horizontal. So what are the two positions? You can't say left, right. Above the x-axis, below the x-axis. So with respect to the x-axis, we have two positions, above and below. With respect to the y-axis, we have right and left. Now when y is equal to a constant, the graph of this equation will be a line parallel to the x-axis. Okay, parallel to the x-axis. Is it above or below? If it's positive, it will be above. If it's negative, it will be below. Now here you have y is equal to a positive 4. So it's above the x-axis. It's parallel to the x-axis and it's above the x-axis because it's positive. If it was y is equal to minus 4, it will be parallel to the x-axis. That will be below the y-axis. Sorry, x-axis. It will be below it. It will be parallel to the x-axis and below it. So you can believe better when we make the graphs. You can believe better. Now I just gave you two examples. But you can see in this example, the line is parallel to the x-axis. In this example, the line is parallel to the y-axis. Here it is parallel to the x-axis, the line, where we have y is equal to 4. It's parallel to the x-axis, but what is the equation? Y is equal to 4. So y is equal to a constant, parallel to the x-axis. Above or below? If it's positive, above. If it's negative, it's a positive 4, so above. If it's a negative 4, below. Here, x is equal to minus 3 by 2. X is equal to minus 3 by 2. So x, no, so it will be parallel to the y-axis. It will be parallel to the y. The graph line will be parallel to the y-axis. So with respect to the y-axis, left side or right side? If it's negative, minus 3 by 2. So left side. Plus 3 by 2, right side. Okay. Now with this knowledge, we'll just try to solve some questions. Yeah. Solve. Okay, so we need to solve x by 3 plus 2 is equal to 2x minus 3 and represent the solution or solutions in the Cartesian plane and on the number line. So what do we mean by this question? When can you represent the solution or solutions in the Cartesian plane? Cartesian plane meaning there should be two variables x and y. See, when you take the x-axis and the y-axis, the plane, I told you, the plane in which the x-axis and y-axis lie is called the Cartesian plane. And when will you take a Cartesian, when will you take up the x-axis and y-axis? Only when you have a table, xy table with values for x and y. That means you should treat the equation as a linear equation in two variables. Cartesian plane means you should treat the equation as a linear equation in two variables. Number line means when will you represent the solution on a number line? If there's only one variable. So that means, no, when I'm talking, please listen to me, children. Don't write. Now see here, this equation, all of you tell me, does it have one variable or two variables?
One variable.
One variable.
One variable. It has one variable. So you can, its solution will be represented on the number line. Its solution will, because there's only one variable, the solution will be represented on the number line. Now they want you to represent the solutions on the Cartesian plane also. That means they want you to treat this equation in one variable as an equation in two variables. That means I want you to introduce y, make an xy table, plot the 3 points, and get the straight line in the Cartesian plane. So this is a linear equation in one variable x. They want you to treat it. They're telling you treat it as a linear equation in one variable x and represent the solution on the number line. On the number line. Okay. Also, treat this as a linear equation in two variables x and y and represent the solutions on the Cartesian plane. No, we need to understand the situation. Only then I can proceed. Yeah, raise your hand if you understood. Madhumita, Krishmika, Danya, Tanishka, Sindhu, Sanjay, Netra, Arjun, Raja, Prajit and Krishmi. Any doubts?
I did not understand.
Sorry?
I did not understand, ma'am.
Okay, which part? And Krishmi? Okay. Yes, Prajit, what's your question?
The Cartesian plane.
This one, the plane which contains the x and y axis. Here, this one. So I think I cleared the slide. So just before you did the graph, no? We did a rough sketch of the graph. That's the Cartesian plane.
Okay, ma'am.
The plane on which the x-axis and y-axis lie is called the Cartesian plane. The plane on which the x-axis plane is a flat surface. Plane is a flat surface. The plane on which the x-axis and y-axis lie is called the Cartesian plane. So your graph paper is a plane surface. Your graph paper is a plane surface. On your graph paper, you'll take up the vertical axis and the horizontal axis. Now this becomes a Cartesian plane. Your graph paper. So this is the x-axis. This is the y-axis. Oh, sorry, not y dash, y-axis. So this is the plane. This is the flat. This is a flat, meaning there's a piece of paper which is flat. It's a plane surface, and on this you have the x and y axis. So this is the Cartesian plane. This is the Cartesian plane, which has the x and y axis in it. Anyway, now the screen also can become a Cartesian plane. The whole screen, if I in the screen, if I draw the x and y axis, the screen is a Cartesian plane. All right. Now let's see the solution, children. Please do not start working. Please listen to me. Now you'll have to solve the equation. Okay, we'll have to solve the equation. So how do you solve it? You solve it in your style. Here, I'll tell you what I have worked. You can solve it in your own style. If you want, you can bring the 2x here, take the 2 to the other side. That is your choice, but all of you will get the same answer. Okay, so I have taken the LCM. LCM is 3. So you'll get x plus, here it's 1, no? So it will be 2 3s are 6. 2 3s are 6 is equal to 2x minus 3. Then x plus 6 is equal to cross multiply 3 into 2x minus 3. Then x plus 6 is equal to 3 into 2x is 6x. 3 into minus 3 is minus 9. Then x minus 6x. X minus 6x is equal to minus 9 minus 6. So minus 5x is equal to minus 15. X is equal to minus 15 by minus 5, which is 3. So the value of x is 3. So you need to solve the equation every time. Nothing like here you should solve, there you should not solve. No, everywhere. If the equation can be solved, if the equation needs to be simplified, you should simplify the equation. So here you have to solve. So when you solve, you get x is equal to 3. X is equal to 3 in the Cartesian plane. That means on the graph paper. On the graph paper. So see here in the Cartesian plane. That means x is equal to 3 means x is always 3 for any real value of y. This is just for your meaning, just for us. You don't have to write this. In the exam, in your exam paper, you don't have to write this. This is just for our knowledge. X is always 3 for any real value of y. X is always 3. So how do you make the table? How do you make the table? xy, x is always 3 for any value of y. For any value of y. And I've plotted, see here in the Cartesian plane, I've plotted. You can see the x-axis, y-axis. I've plotted the points. Please see here. Please see here, what are the points? 3 minus 2. Can you see 3 minus 2 here? 3 minus 2. And 3, 0, 3, 0, 3, 0 here. And 3, 1. 3, 1 here. 3, 1 here. And I joined the 3 points. You can see we got a straight line. See, I've written the address. I've written the address of the points. Okay. And then the straight line. Connect the points, you get the straight line. And I've written x is equal to 3, the equation on it. You can write this. After solving, you get x is equal to 3, right? You can write that on it. X is equal to 3. You can see the scale here. You can see the scale here. And what you also observe, x is equal to 3. X is equal to 3 means the line will be parallel to the y-axis. X is equal to a constant. X is equal to a constant. That means the graph will be parallel to the y-axis. You can see here, it's parallel to the y-axis. The graph of x is equal to 3 is parallel to the y-axis. And since it's a positive 3, it will be to the right of the y-axis. Since it's a positive 3, it will be to the right of the y-axis. You can see it here. Now on the number line. On the number line, we all know it. X is equal to 3 on the number line. See here, you can see the number line below here. X is equal to 3. Yes, please complete this. I told you must have graph sheets or graph book. If there's anyone without a graph sheet or a graph notebook, please make a rough sketch in your, ruled notebook itself. I'm right here, children. If you have any questions, please ask me. I've just muted myself.
Ma'am, how do we find out the value of y in the Cartesian plane?
Value of y in the table, huh?
Yes, ma'am.
Yeah, any value for y, no? I told you when x is equal to 3, that means x is always 3 for any value of y. You can give different values also for y.
Okay, ma'am, but can we just randomly take values for y?
No, you cannot take values for y, and x is always 3. When x is 3, that means x is always 3 for any value of y. I showed you, no, we also checked if these points satisfy the equation.
Yes, ma'am.
When x is equal to 3, it means x is always 3 for any value of y. See, the equation is x is equal to 3. That's what I showed you earlier. Let me write it here. See here. Now, supposing we have x minus 3 is equal to 0. What is this x minus 3 is equal to 0? It's a linear equation and one variable x. How do you treat it as a linear equation? Two variables x and y. X plus 0 y minus 3 is equal to 0, right?
Yes, ma'am.
Yeah. Now, x minus 3 is equal to 0, meaning x is equal to 3, correct?
Yes, ma'am.
Yeah. Now, when you take x is equal to 3, when you take x is equal to 3, that is x is always 3, and give some value, any value for y, like this, say 2. And now check if it satisfies the equation x plus 0 y minus 3. What is the value of x? Supposing we try to check this one. What's the value of x?
3, ma'am.
3 plus 0 into
5, ma'am.
5. What is this? 3 plus 0 into 5 is 0. Minus 3. Minus 3. What is 3 minus 3? 0.
0, ma'am.
Is it the RHS?
Yes, ma'am.
Yeah. So this is what will work.
Okay,
X
ma'am.
is
now-
equal. Yeah.
Completed, ma'am.
Okay, good. So X is equal to A is a line parallel to the parallel. You can write this note below this is a line parallel to the y-axis. The distance so X is equal to A. You can see here X is equal to 3, positive 3. So X is equal to A. What can you comment about the line? It is parallel to the y-axis. You can see it there. X is equal to 3. X is equal to A. Look at the graph and, give your conclusion. It's a line parallel to the y-axis. We can see it there. Yes, it is a line parallel to the y-axis. At a distance of A units, what is the distance between the graph and this? What is the distance between the y-axis and this graph? 3 units. See here, 3 units. 3 units. That means this 3 only. This 3. So at a distance of A units, X is equal to A, right? So A units. To the right of the y-axis, because it's positive 3 to the right of the y-axis. So 3 things you must mention. It's parallel to the x or y-axis. That is the first thing. What is the distance? A units. Which side? Left or right? Right side. It has 3 parts. The conclusion has 3 parts. The line is parallel to the x or y-axis. That you should mention. Then, what is the distance between the line and the x or the y-axis? The distance you must mention. And then if it is to the right, left, above, below, that one. So there are 3 parts. There are 3 parts. So x is, you can see it here, children. X is equal to 3 is like x is equal to A. X is equal to 3 is like x is equal to A. So how is the equation? X is equal to A is x is equal to 3 is a line parallel to the y-axis. That's what I've written here. It's a line parallel to the y-axis. And what is the distance? 3 units. Between the y-axis and the line, what is the distance? 3 units. At a distance of 3 units, that means A units. To the right of the y-axis. To the right of the y-axis. Write on this. Finish your answer and you can just say note and write this. X is equal to A is a line parallel to the y-axis at a distance of A units to the right of the y-axis. Now, why does the question say represent the solutions? Because on the number line, it is a solution, but in the Cartesian plane, solutions. That is why we have S in the bracket here. Because number line, it's only one solution. Cartesian plane, many solutions. Please ask me, children. Have you written this? X is equal to A is a line.
Completed.
Yeah.
Completed, ma'am.
Completed, ma'am.
Fine. So in the bracket, if you want, you can just write this. So x is equal to 3. How do you treat it as a linear equation in two variables x and y? Two variables x and y. X plus 0y is equal to 3, or x plus 0y minus 3 is equal to 0. I'll write it again. X is equal to 3. How do you write it as a linear equation in two variables x and y? X plus 0y is equal to 3. Or if you would take the 3 to the other side, x plus 0y minus 3 is equal to 0. X plus 0y minus 3 is equal to 0. So if you want, you can just take that in the bracket. Your x plus 0y is equal to 3, or x plus 0y minus 3 is equal to 0. Good so far, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
See this one. Draw the graph of the equation 2x minus 3y minus 12 is equal to 0. So clearly it is a linear equation in two variables x and y. Draw the graph of the equation 2x minus 3y minus 12 is equal to 0. Where does the graph intersect the x-axis and y-axis? Now, supposing we have to answer this question algebraically. See, so much of details we cannot learn next year. Next year, directly you'll have to make the graph. No introduction will be given to the graph. 10th standard, nobody will talk about how to make the graph. You will just have the equations. You should know how to make the graph. So it's very, very crucial to learn how to, make a graph for linear equations this year. Next year, teachers will just say that it's a part of 9th standard, so you already know it. So 2x minus 3y minus 12 is equal to 0. Okay, so it's a linear equation. It's a linear equation in two variables, x and y. Now, the question is, where does this line cut the x and y axis? So let's solve it algebraically. Let's answer this question algebraically. Here it is draw the graph. In this question, you have to draw the graph, and then from the graph, you will have to answer where it cuts the x and y axis. So like this, you make the graph, and supposing you get the line like this. Okay, supposing you get the line like this. So it cuts the x-axis here. So this point may be like minus 3, 0. And it cuts the y-axis here. So this will be like something 0, 2, 3, whatever, like 4, whatever. So according to this question, you must make the graph of 2x minus 3y minus 12. So this is the graph of 2x minus 3y minus 12 is equal to 0. You must make the graph, and from the graph, you must, find out where the line cuts the graph line cuts the x-axis and y-axis. But what we are going to now understand is how can we answer this question algebraically without making the graph? Okay. Take down the question, children. So we answered the question without making the graph. That is algebraically, not graphically. Algebraically. We answered the question without making the graph. For this, you should take x is equal to 0 and y is equal to 0. Take x is equal to 0. I'm explaining, children, listen. Take x as 0 and find the corresponding value of y. Take y as 0 and find the corresponding value of x. Take x is equal to 0 and find the corresponding value of y. Take y is equal to 0 and find the corresponding value of x. So when x is 0, what's the value of y? When x is 0, see the screen? See your screen. When x is 0, y is -4. So how do you write the ordered pair? X coordinate, y coordinate, x value and then the y value. So it is 0, -4, not -4, 0. 0, -4. So see a 0, -4. X value and then the y value. 0, -4 meaning where will it be? 0, -4. Just imagine where will you plot 0, -4? Y-axis, no? On the y-axis below 0, -4. It will be on the y-axis. So the graph line cuts the y-axis at 0, -4. When you take x is equal to 0, it is the point where it cuts the y-axis. When y is equal to 0, x is equal to 6. So what is the ordered pair here? 6, 0, because x value first, 6, x value first, 6, 0. X value first, 6, 0, 6, 0. Where is 6, 0, 6, 0? On the x-axis. It will be on the x-axis, 6, 0 when you plot. So that means the graph line cuts the x-axis at 6, 0. At 6, 0. So we found, we answered the question algebraically. When you have to find where it cuts the, x-axis, you must take y is equal to 0. When you'll have to find where it cuts the y-axis, you should take x is equal to 0. And find the corresponding value. Yes?
Ma'am, we found y's value as -4. So when we do the next equation, aren't we supposed to substitute y with -4?
When you substitute y as -4, you will get x as 0. Work it now. Just do it in your book. When you take y as -4, you will get x as 0 again. That's over. For one value of x, you will have one value of y. That's over. When you take x as 0, y is 4. That's over.
Okay.
When you take y as 0, x is 6. For one value of x, you will have a corresponding value of y. That's it. If you again take y as -4 in the equation, you will get x is 0.
Yes, ma'am.
Yeah. I'll wait for some time. Please read the screen. And this is not the answer is correct, but this is not the procedure. We are learning how to, here I've told you how to find it algebraically without making the graph. We'll see how to find the same points graphically.
Ma'am, Yes.
Ma'am, should we put the value of y as 0 or any other constant, ma'am?
No. Because yes, good question. You cannot take any other value for x and y. You have to take x as 0 and y as 0 because we need to find where the graph cuts the x-axis and y-axis. So that means on the x-axis, y is 0. So you should take y as 0 and find the corresponding value of x. And on the y-axis, x is 0. On the y-axis, x is always 0. I'll show you in the graph. On the y-axis, x is always 0. So you must take x is equal to 0 and y is equal to 0. You should not take a different value. That's what I've written here. To find where it cuts, look at your screen right on the top. When you have to find where it cuts the x-axis, you should take y is equal to 0 and find the corresponding value for x. To find where it cuts the y-axis, you should take x is equal to 0 and find the corresponding value of y. Yeah. Now see the graph, children. See the graph. How do we make the graph? See, you can see it here. Where does it cut the x-axis? See here at 6, 0. That's what we got. X-axis at 6. See here. Cuts the x-axis at 6, 0. See here, we got it. See here. And where does it cut the y-axis? Where does it cut the y-axis? At 0, see on the y-axis it's always 0. This is 0, 4, 0, 3, 0, 2, 0, 1, 0, 0, 0, -1, 0, -2, 0, -3, 0, -4. On the y-axis, x is always 0. And on the x-axis, what is this one? 1, 0, 2, 0, 3, 0. Because y is always 0 on the x-axis. What is this point? What's the address of this point? -1, 0, -4, 0. See here, this is -1, 0. This is -4, 0. This is 3, 0. On the x-axis, y is always 0. And on the y-axis, x is always 0. The address of this point is 0, 4. This one is 0, 2. And this one is 0, -4. On the y-axis, x is always 0. On the x-axis, y is always 0. And see here, where does the graph line cut the x-axis? 6, 0. Y-axis, 0, -4. And that's what we found. Without making the graph, we already got the answer. Y-axis at 0, -4. See here, 0, -4. Yes or no, children?
Yes, ma'am.
Yes, ma'am.
Yeah. Now we'll see how to make the graph. This is very important. So to make the graph, take the equation. Take the equation. This is the equation given, correct? Say yes, all of you. Yes or no,
Yes,
whatever. Yeah.
Yes,
Now,
ma'am.
Yes, ma'am.
thank you. Yeah. So now write x in terms of y or y in terms of x. What do I mean by that? So see here, I'm writing x in terms of y. X in terms of y. That is 2x is equal to 3y plus 12. Can you see this? 2x is equal to 3y plus 12. Do we understand that?
Yes, ma'am.
So what is x? Yeah, what is x? 3y plus 12 by 2. This is writing x in terms of y. Writing x in terms of y. When you write x is equal to 3y plus 12 by 2, it is writing x in terms of y.
Yes, ma'am.
Yeah. So do this first. Now for this equation, don't write y in terms of x. Because the coefficient of y is 3. You will get, if you write in terms of y, you will get by 3. It's difficult to find the values when the denominator is 3, 7. When the denominator is 3, 7, 11, it's difficult to find the values. So when there's an option, so what's the coefficient of x here? 2. So write x in terms of y, you will get by 2. It's 2x, right? It's 2x and 3y. So if you write in terms of y, that is if you write y is equal to, then you will get by 3 here because it's 3y, no? So you'll get by 3. You can find, but it's difficult. Slightly, plotting the points will be difficult. So since you have a choice here, you have 2x, write x in terms of y. So you will get by 2 because it's 2x, no? You will get x is equal to something by 2. This 2 will come for division here. Now after that, whenever you write x is equal to 3y, whenever you write x in terms of y, you must give values for y and find the corresponding values of x. So see here, I've given values for y. When y is equal to 0, you can give any value for y. Here you can give any value for y. But take one value as 0. If you don't take 0 also, it's fine. But it'll be easy. Just take 1 as 0. So when y is 0, x will be what? 3 into 0 plus 12 by 2. Correct? Here you should substitute. See here, I've written here clearly. Putting y is equal to 0 in equation 1. This is the equation. Putting y is equal to 0 in equation 1, we get what? X is equal to 3 into 0 because y is 0. 3 into 0 plus 12 by 2. Solve that. 3 into 0 is 0. So 12 by 2, 6. Correct?
Yes, ma'am.
Then when putting y is equal to -2, put y is -2 here. You can take any value, children, any value. I have taken -2. When you take y as -2 here, what will you get? 3 into -2. 3 into -2 plus 12 by 2. So this is -6 plus 12. So 6 by 2, which is 3. And finally, I've taken y is equal to 2. When y is 2, putting y is equal to 2 in equation 1, we get 3 into 2. Y is 2, no? So 3 into 2. plus 12 by 2. 3 into 2 is 6. 6 plus 12 is 18. 18 by 2 is 9. 6 plus 12 is 18. 18 by 2 is 9. X is equal to 9. So when y is 0, x is 6. See here, when y is 0, x is 6. Write it carefully. Then when x is 3, y is minus 2. Write the x and y values in the correct places. Y is minus 2. Y is minus 2. X is 3. X is 3. Then y, excuse me, y is 2. X is 9. Correct?
Yes, ma'am.
Yeah, so fill the values carefully, children. Sometimes against x we'll write the y values and against y we'll write the x values by mistake. Don't do that mistake. So these are the x values, 6, 3 and 9. 6, 3 and 9 are the x values. 0, minus 2 and 2. 0, minus 2 and 2 are the y values. Now we have to, take a graph paper, draw the x and y axis and plot these points. 6, 0. 6, 0 is here. 3, minus 2. 3, minus 2. Here, this one. This is 3, minus 2. Because 3, minus 2. See here, this one. And 9, 2. 9. Where is 9? This is 9. 2. Up it will be here. 9, 2. So these are the 3 points. This is 6, 0. This is 3, minus 2. And this is 9, 2. This is 9, 2. See here, this is 9, 2. Here. This is 2. This is 3, minus 2. Plot the points. After plotting the points, join the 3 points by the same straight line and pull the line, children. Don't be very stingy. Don't connect the 3 points with a small one like segment like this. Extend the line. It's a line. Pull it. Extend the line. See, don't just see the points are here. No, don't just join the 3 points like this and leave it like this. Some children know like this. They'll just join the 3 points like this and they'll leave it like this. And they'll say it didn't cut the y-axis at all. My line did not cut the y-axis at all. No, you didn't produce the line. You should produce the line. It's a line. Be, a little liberal. Like pull the line. Pull the line. It will cut the x-axis and y-axis. That is why the question is asked. So if you just join the 3 points, so like this, if you join the 3 points and put the arrow like this, then you will say, no, my line didn't cut the y-axis at all. It's a line, so you'll have to extend it. And then you will see it meets the y-axis here. It meets the x-axis here. So the graph intersects the x-axis. The graph meaning this line intersects the x-axis at the point 6, 0 and the y-axis at the point 0, minus 4. You should write that. That's asked. Where it meets is asked. Draw the graph. We made the graph. Where does the graph intersect the x-axis and y-axis? So you must write this. This is how you make the graph. And I told you 2x, 3y. Don't use y. Write x in terms of y because 2x, no, so you will get by 2. If it was 4x, you will get by 4. If it is 5x, you will get by 5. So you can make out what the denominator will be. 2x, no, so you will get by 2. So that's easy. Because even if the numerator is 7, 7 by 2, 3.5 only you will get. If the numerator is 7, 7 by 2, 3.5, you can plot 3.5. It will be between 3 and 4. But if it is 10 by 3, which is 3.333 recurring. So if supposing we can't avoid, we have to take, then we'll take approximately 3.4. 3.3, 10 by 3, 3.3. So 3.33 recurring. So you can only show 3.3 or 3.4. You cannot show between that. You can mark between, but you cannot make what at all. So we take an approximate value, 3.3 or 3.4. So for that reason, we want the denominator to be 2 or 4 or 5, something like that, so that we'll get a terminating decimal. So this is how we make the graph, children. All right.
Yes,
Yes.
ma'am. Clear, ma'am.
Yeah, children, now I want you to complete this one. 1 minute, 1 minute. I thought there's another graph. Oh yeah, this one. Yes, the third one. Take a screenshot of this one just in case you have not finished it or you don't have a graph paper. Please take a screenshot of this one. Do your graph neatly, children. Done?
Yes,
It's
ma'am.
time
Yes,
for the
ma'am.
next class, children. Yeah. Now, yeah, take a screenshot of this one. You can understand. You can understand. I told you how to make the equations. I'll explain it in the next class. Just try to, understand this and make the graph.
Taken,
These
ma'am.
these two lines, you make the two lines. So you cannot fully understand this. I will explain this in the next class. Just try to complete the graph. All right, children, it's time for my next class. All of you took a screenshot?
Yes, ma'am.
Yes, ma'am.
All right, children.
Yes, ma'am.
All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Thank you, children. Thank you.
Thank you, ma'am.